Good afternoon. Today we are going to talk about data optimization, and of course data optimization means kind of deduplication and compressions, of course. We can talk also about thin provisioning. This will help also to optimize your data, but the main focus will be deduplication and compression. Let us go to our agenda. So we will introduce our demonstration environment first, then we will show how to create the volumes using deduplication and compression, what kind of options we have here, what kind of ratio we can expect. Then we will show the live demo with the real machines, and then we will see what kind of data optimization we can expect. And then we will run some benchmark to see if this optimizing of data has a big influence on performance or not. Okay, so JovianDSS is a very rich features product. The red lines, so it's our focus today, so online compression, online deduplication. There are plenty other features which we are focusing last weeks, and the next weeks we will go step by step, demonstrating and showing how it works, how is it good, what about the best practices. So today data optimization, and in order to demonstrate this we have prepared very simple test environment. That is the actually I will be demonstrating half of this because I will be showing one node. There will be no cluster today. We don't care about high availability today at all. I will have here VMware, and on top on VMware we are running JovianDSS, and as a virtual storage appliance, so we also use our hyperconverged environment. And then we will have, of course, some Windows machines or maybe some Jovian machines also installed in this environment. So let us switch to our demonstration environment. So as I mentioned, we have one node ESX. It is extremely simple installation. I will show you the configuration. So in networking, we have one virtual switch, and I have here another two virtual switches just for iSCSI multipath. Okay, in storage, as you see, we have the local disk, which is used to install and boot ESX, and on the local disk we have also Jovian. So because we need to boot the Jovian just after booting the ESX. So when I go inside, you see I have a Jovian. That's my Jovian virtual storage appliance, and that is exactly this machine. So that is my Jovian, which is running directly on ESX. And ESX, of course, we have a HBA with hard disks here. So if I go to advanced settings, that is the LSI SAS HBA, which is configured as a direct path, so pass-through device. And when I go to my Jovian and in settings, then my Jovian, it is using this LSI HBA as a private PCI device. Okay, so thanks this, we stick this virtual machine, this Jovian, to this host, and we have a good performance because the Jovian is having a kind of direct access to the HBA. Okay, I will switch now to the web GUI of our Jovian. Okay, and then I will show how I have already created pools here. So I have a pool 0, and the pool 0 consists of few mirrors. So I have a mirror 0, 1, 2, 3, 4, 5 mirrors, and I have one write log device. I don't have a read cache device. Of course, read cache is in RAM, but SSD to extend this RAM read cache doesn't exist here. Okay, so that's the pool 0, fast because the mirrors, and then pool 1. And on pool 1 we have installed just one single dual parity data group. So we have here 8 disks, and this is a RAID Z2, means 2 disk parity. So our user capacity is 6 disks. The 2 disks always used for the parity. Of course, this is distributed, so but in the final capacity calculation, we can always say RAID Z2 means a number of disk minus 2. Okay, and important to our demonstration today is that on pool 0 I have here one target. Actually we have more, but one is important. This zvol00, the capacity is almost 5 terabyte. So here it says 4.88 terabyte. And when I go to edit on this volume, so we can observe that, yeah, we have deduplication switch to on. Default setting is off. So when you create your volume, you need to decide whether you want to switch it on. Jovian is ZFS based, so ZFS has a online deduplication algorithm. There is no offline deduplication here, only online. So the deduplication is working while the user is writing the data online. So when the user is writing the data, this data, of course, in the very simple explanation will be that the data is divided by, you know, kind of small parts, and these parts are shown here. The volume block size, or sometimes call it a record size. The default value here is 128 kilobyte. So every 128 kilobyte piece of data has a so-called data stamp calculated, kind of hash. So this is a short string of the alphabetic characters, and this is representing this 128 kilobyte block. This short string goes to memory, to RAM, to the table. So the table is growing, of course, when the unique data are coming. So every new unique 128 kilobyte block will be having a one entrance, next entrance with this string or hash, how you call it, into this deduplication table. So you need to know that more data you have, then more space you will need to store all these the data stamps, right? And also longer, bigger table maybe can have influence also on searching this table to finding whether the data is unique or data is duplicated. In our release notes, maybe I will show you here, when you click on help, then you have a list of the release notes. So I will select one of latest, or actually the latest release note. Here this information didn't change a lot, but when you scroll down you will find essential information about plenty different things. Also the duplication recommendation is here. Here there is a calculation which is taking in consideration extreme situations when all your data is unique, so the data is not deduplicated. So how much space you will need in this deduplication table. So this deduplication table will be using 25% of the so-called arc, so the in general kind of read cache, which is used in the system, and currently we are using 75% of all your RAM will be used for so-called arc read cache, and then 25% of this arc will be used for the duplication. Of course, if there is no enough space, then this table will grow to second level of the arc, which will be placed on the SSD device. In my setup, I don't have this SSD device, but if you will have a real production and more space for the duplication needed, then of course you must have a SSD for to expand the read cache. Okay, so in this situation you will see that using 128 kilobyte block, which is our default, is kind of using this in the safe way. You know, you don't need so much space to do it. Of course, it will be drastically grow if your block size will be smaller. So unfortunately, we didn't update this information. I see we have an error here. It's not 0.5%, but it's 0.75%. Okay, so that need to be changed. We will fix it soon. Okay, so that was the consideration of how much resources you will need to do it. Okay, but if your data is good duplicated, you will be really surprised how good it is working and how good job it is doing for you. Okay. On second pool, I have created also iSCSI volume. This volume, you see, it exists, but it's not assigned to any target because I'm using this also for another disaster recovery demonstration. Okay, so this zvol here is same size, and let us see what is the difference when I go to edit. The duplication is disabled here, but compression is enabled here. Okay, so we have just the standard situation that compression is enabled on pool 1, and on pool 0 we have both enabled. So the compression is enabled and the duplication is enabled. What about compression? So the default algorithm for compression is LZ4. This is algorithm which is very modern, working almost performance transparent for the user. It is not easy to prove a performance degradation or performance improvement here. So the performance is, you know, we can say in general transparent for the user. We can even expect in some situations better performance, because when you will squeeze your data, the 6 on the rotational disk will be shorter, and potentially we can have even performance improvement. Very simple, just 0, so ZLE performance, so very simple algorithm. So very seldom used, but if you will have a real kind of zero intensive applications, then you can select this algorithm, and that's the classical gzip algorithm. So the 1 to 9, of course the 9 is the most efficient in case of space, but is less efficient in case of performance, and the opposite one is the fastest one, but not necessarily good compression ratio. Okay, and there is also an older algorithm, LZGB. And actually LZ4 is much more efficient, and this is why this is a default algorithm. Soon we will have another algorithm. This is in the roadmap, which will be more efficient and only very little difference on the performance. Okay, so here there is another parameter, which is so-called sync. We have the write log device, so we can use sync enabled, and we can have all I/O synchronous. But we can also check when we want to have the highest performance, then we can use the disabled. So in this case, the system will be behaving like hardware RAID with RAID back, but without battery, right? So in such situation, when you have an uninterruptible power supply, this is kind of okay. But if you have a mission critical data and everything need to be synced, of course, please always use sync always, right? So that is our setup, and let me show you our storage. So this iSCSI 0, here you see it's 488. That is exactly the volume from pool 0, which is exported here. It is exported via this target, right? So when I go to host, so storage adapter, and I can show you properties. So that's my target 0. It is exported over 2 IPs. That's my IP, because the IP I'm using kind of virtual IP, right? So even this is not a cluster at this moment, I have option to export my resources via virtual IPs, right? So I was configuring 2 virtual IPs because on my Jovian I have here 3 network adapters. Very easy. I can also show you the setup of this machine. Okay, so I was installing these 3 network adapters. That's the VM network, that's the 21 network and 31 network. So we have this 21 and 31 network, and I was showing you already in the networking that I have these 2 switches, this 21 switch and 31, right? And of course this VM network 21, so this Jovian has also connection to both switches, that I am able to export this iSCSI via these switches, okay? And then I was able to go to my storage adapters, here, and configure these 21 and 31 with target 0, okay? I was also assigning these switches here, and that is my volume. This volume has also round robin, okay, and finally I have the iSCSI disk data store, okay? And on this iSCSI disk data store, a very important information here, we have 1.37 terabyte stored data. The data is coming from all these virtual machines which I have here. So you see that's all the virtual machines. Every machine is actually identical. So because all of them are just Windows 2012 R2, and the standard installations so just about 40 gigabyte per machine. So when I will just go to this machine, edit settings, you see I have 40 giga hard disk, and you see that's exactly 41 giga used. Okay, so every machine is identical, and we want to see how efficient the duplication will be. These two Jovian are a bit of course they are different than the Windows, that's obvious, but in Jovian we have just in every Jovian we have mapped 100 giga disk, so it's mapped, so it's only on this is only just 16 giga. So there are two Jovians, small, and more than 20 Windows with 40 giga disk. So this in total is giving us is 1.37 terabyte, right? So I'm curious now how efficient the duplication is. Okay, so maybe first let us see how efficient compression is. I am saving the data on exactly on this iSCSI target, right, on this volume, but I am also replicating the data using our ODPS, Offsite Data Protection Service. So when I go to this ZVol, you see the every minute, so now it's 25 past 4, and you see every minute I have a snapshot taken automatically, and every minute data are moved to my pool 1. So I go to snapshots, I can prove it to you that on ZVol 00, okay, it's exactly 1625, that's the last snapshot. In a few seconds we will have a 1626, that will be next snapshot. So every minute, if there is a new data, will be also replicated to this pool 1. Okay, so I'm curious how much space I need to store this on my compressed volume. So when I go to pool 1, okay, and click on Run Scrap Scanner, Scrap Scanner will show me exactly the physical space which is taken by this data on this pool, right? So it showed me 204 gigabyte, okay? So how efficient it is? I have here on my, from the VMware point of view, I have 1.37 giga, so 1.37 divide by 0.2, so that is 6.85. So almost 7 times this data was squeezed. Of course, it is of course okay, because this 40 giga, the machines are installed and there are just few testing data on the machine, so it's not a lot. So probably half of this machine is just a reserved disk, so that is compressing perfect, and maybe some other data are also compressed somehow, but the ISO, of course, plenty of the exec is not compressing very good. But finally, this is extremely good result if I am just considering my virtual machine images. Okay. Yeah, that's great. So now it's the question what we can expect when I using the duplication. You know, I have 20 or more than 20 identical machines, so the duplications still need to improve, so must improve this result. Let us run the scanner on the pool 0 when we have the duplication and compression working together. Wow, that is really good result. So so I would say 1370 divided by 16. Wow, that is really very big result. So 1370, right? 1370 divided by 16. Okay, I'm getting 85. So the ratio is really impressive. So if you will have the storage with so many virtual machines, you can really save a lot of space, and that will be working also very efficient. Let us see what happened when I will go and create one more machine. So the 0 I was not starting, because then copying will be simple. I don't have the vCenter here, so I don't have a cloning, so I can just copy. Actually, I have vCenter, but older version, so it didn't work now. So I can copy this data from this machine 1, and then when I create, let's say, the do clone 23, right? So next one. Okay, let us copy everything here. So it was 1.37. So after the copying, of course, we will have more space. And we remember here when we were running scrap, it was 15.9, right? And now we can check what's going on. So we remember here it was 15.9 and here it was 204, right? So let us check what happened when I was copying one more 40 giga virtual machine. 204, now it's okay, 212. Now we have 8 giga more on the pool, which is compressed only. And here was 15.9. What happened here? 15.9, 16.1, so 0.2 giga more. That's okay. I think we are happy with this result. We can see that the duplication is really working well. Then let us go and check again some performance value. We are on the volume which is using the duplication and compression. I'm testing not a big file, but you see the volume still need to run this algorithm, and my virtual machine is having here with the 4K pattern something like on the mixed random 22, almost 23,000 IOPS and 93 megabytes per second. When I will go, let's say 32K, okay, then we go to something like almost 500 megabytes per second. It is, of course, when I do last update, it is showing a current value. When I go to start, it will be showing the average. Okay, so average data is something like 430 megabytes per second, and then here 13,000 IOPS. Yeah, that's very good performance, and the duplication and compression is working at the same time. We can also check with 8K. Yeah, then we have 20,000 IOPS. Okay, so we are done with our goal agenda for today. Let me see if there are questions. Oh, there is no question, so everything looks clear. We are very happy. Everything was working super today. I would like to point you that webinars are coming. So next week we have already next webinar planned. So watch our invitations. And I will just say thank you very much for today, and we hear you soon. Thank you very much. Bye.